The training package TP8015-3 from Festo Didactic is a practical learning solution for building fundamental skills in electrical technology. It provides the necessary training equipment to study and engage in hands-on experimentation with DC power circuits, single-phase and three-phase power circuits, as well as single-phase and three-phase transformers. Complete courses are available to speed up lesson planning and guide students during lab sessions. They feature the necessary theory as well as step-by-step learning exercises. Courses are available on the FestoLX portal or as PDF workbooks. Let's look at the hardware included in the training package. First, note that most modules are protected against short circuits, overvoltage, and overcurrent, as they are designed to endure many decades of lab work. Modules can be used as tabletop devices, although it's more practical to insert them in a workstation equipped with standard A4 rails. For each exercise, students wire the modules with safety lab cables according to the electrical schematics provided in the courses. To study DC circuits, students can use our versatile dynamometer and power supply module configured as a DC power supply. In this mode, the unit can act as a variable DC voltage source up to 150 volts positive or negative, or as a current source of up to 5 amp positive or negative. Please note that this power supply is reversible, as it can both source power and sink it. For AC circuits, the dynamometer and power supply module can act as a variable 50 Hz or 60 Hz voltage source. With the resistive load module, students can connect up to 3 resistors in parallel in each phase of a 3-phase load, thanks to its 3 banks of identical resistors. It can also be used to form series, parallel, and mixed circuits for single-phase and DC experiments. The same 3 banks of 3 components structure is used for the capacitive and inductive load modules. Now, let's talk about the module that supports digital data acquisition. To make measurements easy to perform and understand, students use the data acquisition and control interface that offers 4 voltage inputs and 4 current inputs, all optically isolated. This data is then sent to the computer via a USB link and is used to display all relevant parameters: active, reactive, and apparent power, power factor, efficiency, impedance, phase shift, and so on. Instead of using precious lab time to copy experimental data, students can use the automated data table and quickly create meaningful graphs. With our LVDAC EMS software, students can easily understand the abstract concepts of phase shift, reactive power, and power factor in AC circuits. Using powerful instruments like this phasor analyzer, they can clearly see what happens when they change the nature of the load. By observing the voltage, current, and instantaneous power waveforms on the A-Trace oscilloscope, they will gain yet more insights into these concepts. The same instruments will help them in the study of single-phase and three-phase transformers. In summary, the training package AT15-3 ensures that students develop a strong practical understanding of electricity, providing a solid foundation to build on as they advance to more complex topics. Thanks to its modular design, the training package can be easily combined with other packages or expanded with individual modules to cover topics in power electronics, electrical machines, and renewable energy. It is a cost-effective solution that adapts to evolving training needs and budgets.